Hello, Math 2. This is Mrs. Bricky, and this is video for Unit 8, Lesson 3. This is Part B. So this is the second half of the lesson. So we've learned several strategies for solving quadratic equations so far. We've learned how to factor, we've learned how to use the quadratic formula, and we've talked about the square root method. So the question becomes, how do you know which strategy you should use when you see a problem? So I have 6 problems for you to look at and think about which method you would choose. And in class, we kind of shared our reasons, but this is a video, so I'm just going to kind of talk about them. The first strategy that we learned is factoring. So when we factor, we're looking at something that's in standard form, and we're trying to come up with a combination of factors that work. So example C is a good example of a factorable equation. 12 has 3 combos, 1 times 12, 2 times 6, and 3 times 4. And in this case, my quadratic that I'm trying to solve has a negative 1 as its middle coefficient. So I can use a combo of 3 and 4, x plus 3 and x minus 4. So this one is factorable, and factoring is pretty, it doesn't take a lot of room or work to do. So it's a great strategy if it works, if it's factorable. So we've got x equals negative 3 and positive 4 as our answers. These other standard form ones, we've got several others here that are standard form A, D, and E. And sometimes it's a little bit harder to know if it's factorable. D, for example, actually I can tell is not factorable because I've got my list over here for 12, and I can't see a combo that would help me get a negative 2 in the middle. So if it's in standard form and it's not factorable, then you'll have to apply the quadratic formula. So if we solved this one, it would be x equals negative b plus or minus the square root of b squared minus 4 times a times c, and that is all over 2a. And our root here, calculate that inside number and my root, negative 2 squared minus 4 times 1 times negative 12. That is 52. Square root of 52 does simplify. In your calculator, you'll simplify that as 2 root 13. And so we can even reduce the fraction 1 plus or minus root 13. So we had to use the quadratic formula in that case because it was not factorable. For A and E, it's a little harder to see if it's factorable. Sometimes that just means you have to try to factor it. Or if you prefer, you can just go straight into applying the quadratic formula. Let's see, trying to get a 3 here. I think this one might be factorable. Let's see, 6 and 2 multiply to give me 12. This would be a 12x and a 2x. Nope, oh, it was close. That would not give me a 3 in the middle. And, I purposefully did not think about these 2 quadratics ahead of time because I wanted to show you that sometimes you just have to kind of think about it. Let's see, 3 and 4. Nope, that's not going to work. It looks like maybe this one's not factorable. I can't see a factorization of it, so let's try the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac, that's a 12, all over 2a. So this will be 3 plus or minus a root over 2. So in this case, the root is negative 3 squared minus 4 times 2 times negative 12. Sorry about the handwriting on the negative 12. That's 105. Ha! So we were right. It's not factorable because the square root of 105 does not reduce. And so that is just our answers. Oh, except I do have an error. That should be a 4 on the bottom because it's a 2 times 2. Sorry about that. So E was not factorable. We tried. We couldn't find a combo, so we turned to the quadratic formula. Let's see if we can factor A. Let's see, we're trying to get a 5, and the 2 is going to multiply by whatever number I put there. So I think we can use the 3 and the 4 here because 2x times 4 gives me 8x, and 3 times x is 3x, and we can get a negative 5 if the 3x is positive and the negative 8 and the 8x is negative. So let's see. If we want the 3x to be positive, we'll put a plus there and a minus here. So we were able to factor this one. And again, sometimes you just want to try to factor it. If you can't come up with a factorization, then you can try the quadratic formula. So our two solutions are from this factor on the left, 4. I mean, that's the right. Oh, I'm so good at right and left. And the other factor, if you need to write this one out, it's a little trickier. So go ahead and write it out if you need to, or you can do it in your head if you can. So this gives me 2x equals negative 3. So when I divide by 2, I get x equals negative 3 halves. So there are my two answers to that one. Now, the other two equations are not in standard form. And when they're not in standard form, that's when you might want to apply the square root method. If you see something that looks kind of like vertex form like this, that's definitely a case for rooting to solve. Or even if it had looked like this, we would probably want to use the square root because there's no middle term. And if there's no middle term in standard form, you can also apply square rooting. So let's solve these two. I'm going to start with B up here. I'm trying to isolate the square. Now that I have the square isolated, I can root both sides of my equation. Don't forget your plus and minus symbol. That leaves me with x minus 5 equals plus or minus root 12. And if I simplify root 12 in my calculator, that's 2 root 3. And my last step would be to add 5. And the 5 is not going to combine with that root. It's going to be 5 plus or minus 2 root 3. And on F, we can also apply the square root method. We want to isolate the square, so we want to start by dividing by 5. So we get x squared is equal to 12, and then we can apply our square root to get x equals plus or minus 2 root 3. So each of these equations had two solutions. If your function is in standard form, you can try factoring it. If factoring isn't working, try the quadratic formula. If you have something that looks like it's in vertex form or it just has a square and a constant, then you can apply the square root method. All right, so Mrs. Brickey created a graph of three functions, but she forgot to label them and forgot to include any numbers on the coordinate plane. Silly me. These are the three functions that I graphed. Thinking about the y-intercept of the function, which function goes with each graph? So we are thinking about y-intercepts right now for a second. Y-intercepts occur at the x value 0. So this y-axis is where x is equal to 0, and we are looking for where do the functions cross that line. So that means if we sub 0 into our functions, we will get the y-intercept. F of 0 here is 0 squared minus 3 times 0 minus 18. So the y-intercept of this first function f is negative 18. G of 0 is 0 squared minus 3 times 0 minus 5. So G has a y-intercept of negative 5. And This last one, h of 0, it's a different form, but we can still just sub in 0 for x. Negative 3, 0 minus 3 squared minus 5. So make sure you would type it in your calculator just as I have it written. And that one is 4. So now that we can see what their y-intercepts are, we know that this one that's the lowest has to be function f. This other one that's negative but much higher, that has to be function g. And function h is the one that has a positive x-intercept of 4. Okay, let's try one more. Oops, I did it again. Another unlabeled, unnumbered graph. The struggle is real. The three functions that I graphed this time are k, m, and p. This time, our job is to figure out what the 6 x-intercepts are, and I have labeled them on the graph as A, B, C, D, E, and F. We're going to try to find all of those x-intercepts. So let's start. Let's just pick a function. Give myself some space to work here. Let's just start with function k. Function k, let's see. We'll just start at the top and go through them. Function k is x squared plus 6x plus 2. So if we tried to factor it, our ending number, our constant here is 2. The only possibilities are 1 times 2, and we're trying to get a middle term of 6, and we are not going to be able to do it. So we can't factor it. If we have a quadratic in standard form that is not factorable, we have to apply the quadratic formula. So if we apply the quadratic formula here, we get x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so we have 6 squared minus 4 times 1 times 2 under our radical. That's a 28. So negative 6 plus or minus the square root of 28 simplifies to give us 2 root 7, and that's all over 2. We can reduce that fraction. That's negative 6. Oh, sorry, I'm reducing. Haha. Negative 6 divided by 2 is negative 3, and then 2 root 7 divided by 2 is just root 7. So it's negative 3 plus or minus root 7. Now, when I'm looking at a graph and trying to decide where things are, that might be a little bit tricky. So I'm going to go ahead and just get the 2 decimal values from that. Negative 3 plus root 7 is about negative 0.35. And negative 3 minus root 7 is about negative 5.65. So I have the first two. Now I can't really determine based on my graph which ones those are yet, but I have them. And in a minute, when I start getting more of my answers, I can start thinking about which ones go where. Okay, let's try m of x now. M of x is x squared plus 6x minus 7. So if we have standard form, it's a good idea to try to factor it. Our focus number is 7, so 7 is 1 times 7. And hey, we can get a combo to equal 6. It just needs to be x plus 7 and x minus 1. So our two x-intercepts here are negative 7 and positive 1. Now, it turns out if you look at the coordinate plane up there, only one of the intercepts is positive. So we know that the value of f is 1. And these two are on the same graph. So if 1 is f, that means b has to be -7. Okay, so I'm going to make a little list. A, B, C, D, E, and F. So we now know that B is -7 and F is 1. Okay, well, we have one more equation. Let's go ahead and work with it. P of x is x plus 6 squared minus 4. We're trying to find the zeros of this function, so we're thinking about when does x squared minus 4 equal 0. So we're going to throw that into, no, we're going to use the square root method. We're going to add 4. We get x plus 6 squared is equal to 4. We can square root both sides of our equation, plus or minus. So this is x plus 6 is equal to positive and negative, and the square root of 4 is 2. So we've got an integer over here on the right side. So we're going to split it into two equations. We are going to split it into x plus 6 equals 2 and x plus 6 equals -2. And to finish up, we're going to subtract 6 from both sides. And we get x equals -4 and x equals -8. Okay, so look, we have A, C, D, and E left to label. We know B is -7, so that means A has to be -8. And that means the other 0 on that parabola, the D, that's got to be the -4. And if we look at the first two that we found, -0.35, that's got to be E. And I'm going to write it in its radical form. So that's -3 plus √7. I'll write the approximation there too. So this is -0.35. And then our last one, C, that's 3 minus √7, which is about -5.65. So we found all the values of those x-intercepts. All right, so that is it. The homework assignment might be an Edulastic for you, might be on paper. Get your assignment from your teacher and let us know if you have any questions. Thank you.